So MATLAB has a lot of really nice data analysis tools, including a curve fitting tool. Some curve fitting in MATLAB can be done on the command line, but a lot of really nice tools are built into one in the curve fitting tool, which you get by just typing in CF tool. I made two randomish arrays, and we're going to try and fit the data. I don't really expect any good data to occur. We probably won't get a very good fit, but that doesn't really matter. Note that you have this option to do weights. We're not going to use that in this class. You use weights when you want to exclude a data point or try to fiddle with your data to see if you can get a better fit by not considering certain points as much. It's very good if you want to do fits for experimental data. Don't do it here. Just don't worry about it. So create your data set. You don't need to smooth it, so just close. So now you want to fit the data. So you go to fitting and you can do a new fit. You're given a lot of options: custom equations, exponentials, Fourier, Gaussian, etc., etc. Custom is actually kind of fun to play with, although you shouldn't need it here, where you can add different terms and do really random functions. It's fun to play with. Probably not something you'll ever use too much, but let's say we want to see if a Fourier works here. So we're going to apply the fit, and it will give you the values for all of the coefficients that it finds. You have the option of setting some bounds. Those will vary depending on what kind you pick. If you pick to just do a polynomial, you'll be able to pick lower and upper bounds for your coefficients. So if we do that, you can see we get actually a not horrible fit by doing that. So let's keep that. So now we want to do things with plotting. When you do that, you can just say what you're plotting, and you can clear associated fits. But exclusion is something you won't use. This is if you want to exclude a data point. If you think it sucks, if it's an outlier, it's ruining your fit, don't do it here. You might do it when you're working in lab. But now the one thing we do want to do is look at the fit, because this is nice, but you don't really get to put an x-axis label on it or a y-axis label, and that's not really nice for when you're doing your homework. So let's apply that, and you can see how it looks. And you can use the different plotting tools in order to make this look a little bit different, but overall this gives you a good comparison of your experimental data to your fit. It's worth knowing. This is actually a little bit easier to use than Excel. I would use this instead of Excel on your exams, unless for some reason you don't have the Caltech network, in which case Excel is your friend.